Okay, this is exam 3 for physics 101 in fall 2019. Okay, first this guy pulls a 10-kilogram block 5 meters across the floor with 25 newtons of force at 30 degrees from the horizontal, and there's the coefficient of, that should say kinetic friction, I'll fix that, between the floor and the block is 0.1. What is the frictional force on the block? And then what is the total work done on the block? So this is really sort of a throwback to chapter 4, but also chapter 5. My first step is to label all the forces. I have the normal force, Fn. I have the weight, Fw. I have this kinetic frictional force, Fk. And then I have this 25 Newton force. I'm going to go and resolve it into its components. 25 cosine of 30, and then 25 sine of 30. Oops. So those are all the forces that I have at play. In order to find the frictional force, I know that the frictional force, Fk, is equal to mu k times Fn. So in order to find that for part A, I need to first find what is the normal force. And to find the normal force, I look at these forces in the y direction. I say the sum of the forces in the y direction are equal to 0. That's 25 sine of 30 plus Fn minus Fw. That's equal to 0. And if I do that, I can find Fn, which is going to equal Fw minus 25 sine of 30. Let's see, Fw is 100 newtons. So I get 87.5 newtons for Fn. And then my Fk will equal to 0.1 times that. And so that's 8.75 newtons. So that's the first answer. Now for part 2, I want to know the total work. And I have two forces that are doing work. I have this force and this force. And so the total work will equal to that first force, 25 cosine 30, times the distance. And it tells me that it moves across 5 meters, times 5 meters, minus the work done by the frictional force, which is 8.75 times 5 meters. And so that's going to equal 4.3. Is that right? Let me just double check that. Doesn't seem right. No, 100.8. Just had a calculation error there, sorry. So I'm just going to call that 110 minus 8.75 times 5, which is 44. I get 65 joules. Or 66. It depends how you round. I actually rounded in my calculator. So if you rounded this way, it'd be 66. 66 or 65 joules. And then that's the second answer. All right, in this figure, the bead has a mass of 1 kilogram. It has a speed of 2 meters per second at point A, goes down the slope. What types of energy does it have at point A? Well, I know it has potential energy, but because it also has a speed at point A, it also has kinetic energy. So at point A, it has both. And then what is its velocity at point C? At point C, it also has both. So I'm going to set up my conservation of energy like this, where this is at point A, point C, and point C. And that's going to be mg times 5 meters. That's the height at point A, plus 1/2 m of 2 meters per second squared equals mg 2 meters plus 1/2 mv squared. And notice that my masses will all cancel. So this is 50, so half of 4 is 2, 20 plus 1/2 v squared. Uh, 52 minus 20, that's 3264. And so that's V is equal to 8 meters per second. Hold on just a second, I need to double check my math there. All right, So V is equal to 8 meters per second. That's the answer to the second part there. All right, number 3, flywheel and engine is at rest. That means omega naught equals 0. Then the engine is turned on, and the flywheel accelerates at a rate of 4 revolutions per second squared. So alpha is equal to 4. And I want to know through how many revolutions does it turn before it reaches a final angular speed, omega, equal to 12 revolutions per second. And then how long does it take to reach that? You actually have to work part B first, because I want to know t and I want to know theta. But if I look at theta, theta is equal to omega naught t plus 1/2 alpha t squared. Now this term goes to 0 because omega naught is 0. But I don't know theta and I don't know t. So I need to find t first. But if I look at my other equation, this is 0. I can find t because I know omega is equal to 12 equals to 4 times t. I can keep this all in revolutions, that the revolutions will actually cancel one another out. And so t is equal to 3 seconds. And then I take that over here, and I get theta equals 1/2 of alpha, which is 4, times 3 squared. That's 18 revolutions. So there's my answer to part A, and that's my answer to part B. Consider this collision, which energy is not conserved. What type of collision is this? This is an inelastic collision. And to find the final velocity, I say PI is equal to PF. PI is 1 kilogram times 3 meters per second plus 2 kilograms times negative 4 meters per second. And then that's equal to 1 kilogram times negative 1 meter per second plus M2 times, or let's see, I know M2 actually, 2 kilograms times V2F. Let's see, I'll change this. Let's just say 2 kilograms. Okay, so now I can solve for V2F. I get 3 minus 6 equals negative 1 plus 2 V2F. Negative 3 equals 1. Hold on just a sec, I have to take a break. Let's see, actually I made a mistake here, I'm sorry. This should be 8, and then that makes this negative 5, and this negative 4. So V2F is equal to negative 2 meters per second, and since it's negative, it's to the left. I'll be looking for that direction. Okay, let's do the multiple choice. 10 kilogram kid comes down a slide. The slide is 3 meters high and 5 meters long. So it looks like this, 3 meters there, 5 meters here. The slide has a frictional force of 10 newtons that acts along the entire length of the slide. So my frictional force is 10 newtons all along that slide. How much work does friction do on the kid as he comes down the slide? Well, work is force times displacement. And in this case, that force is my frictional force times my displacement. It's going to be 10 newtons. It acts along a distance of 5 meters, so it's 50 joules. Cardboard box has a speed of 6 meters per second as it slides across the floor. There's the coefficient of kinetic friction is 0.2. How far does the box slide before coming to rest? So all this kinetic energy, 1/2 mv squared, is going to go into the work done by friction. Oh, I don't know the mass. Oh no. So mv squared, but if I look at this frictional force, it is equal to mu k times the normal force, which is m times g. And so my masses all cancel out. And so I'm looking for d. So 1/2 of v squared equals 0.2 times 10 times d. That's 18 divided by 2 equals d. That's equal to 9 meters. Oh, sorry. Box slides across the floor and feels a frictional force. How can you best describe the work done by the frictional force? It's negative work. Ball is tied to a string. The tension does no work at all because the tension is in this direction, but the displacement is in this direction, or the velocity is in that direction. Girl throws a ball straight up with a speed of 10 meters per second. How high does it go up? Well, down here it only has kinetic energy. Up here it only has potential energy. So I say 1/2 mv squared equals mgh. Masses cancel. And I have 1/2 of 10 squared equals 10 times h. That's 5 meters for h. I divide through by 10, gets rid of that, and that 1/2 of 10 is 5. That's equal to h. Consider this figure. 3 blocks of mass m slide down different inclined planes, each having a height h. The inclined planes do have significant friction. Which block is traveling fastest? It's the block that loses the least energy to the frictional force, which is the block that travels the shortest distance. So A is the right answer. What is the basic SI unit for power? I know power is energy over time. And so that's going to be, well, 1/2 mv squared over t. I'm just doing the dimensions now, so I'm just going to drop that half. So that's kilogram meter squared per second squared, and then I have another seconds over here. So it's kilogram meter squared per second cubed. Spring-loaded gun shoots a .02 kilogram steel ball. There's a spring constant. That's K. This is M. This is the height. What is the compression and the spring in the gun? So I have this ball, and then it goes up to a certain height. Initially, it only has elastic potential energy, and then it has gravitational potential energy. I'm looking for H. X. Oh no, I'm looking for X actually. Sorry, let's go back. X is equal to 2mgh divided by k, and the square root of all that. That is the square root of 2 times 0.02 times 10 times h, which was 5, divided by k, which is 250. And that was equal to 0.089 meters, or 8.9 centimeters. Number 9, if a person with a mass 60 kilograms standing still throws an object with a mass 2 kilograms, so it has an object he throws in that direction, it does 2 kilograms at 20 meters per second. I want to know what is the recoil velocity of this guy, and his mass is 60 kilograms. So initially their momentum is 0 because nobody's moving, and then the guy, which has 60 kilograms, has some V final plus 2 kilograms times 20 meters per second. So VF equals 40 divided by negative 60, or negative 2/3, or negative 0.67 meters per second. So A, but I was just looking for the speed, so we'll just leave off the negative. Apply a force of 20 newtons to a 10 kilogram mass for 3 seconds. Object is initially at rest. What's its speed after 3 seconds? So this is a thing that we could do with Newton's second law and laws of motion, but because I know Newton's second law in this form, makes it a little easier. I'm looking for the speed. I know that VI is 0, so that's 0. So I'm just solving for VF. VF equals F delta T over M. That's equal to 20 times 3 divided by the mass, which is 10, equals 6 meters per second. Cart is rolling along a frictionless track. Rain is falling into the cart. That means the mass is increasing. The momentum must remain constant. So if m is going up, that means v is going down. You have a particle of mass m and increase its energy by a factor of 3. What happens to the object's momentum? Okay, so the energy has increased by a factor of 3. That means that the velocity or speed has increased by a factor of root 3 because it's squared, and root 3 squared is equal to 3. Now, the momentum is a linear direct relationship with v, so whatever I do to v, I'm also going to do to the momentum. So E is the right answer. What is the angular velocity of the second hand on a clock? A second hand has a delta theta equal to 2 pi radians and a delta t equal to 60 seconds. So 2 pi over 60, that's 0.1 radians per second, because pi is about 3. So 2 times 3 is 6, divided by 60 is 0.1. A Ferris wheel with a radius of 30 meters rotates at a speed of 0.2 radians per second. So omega equals 0.2. It's already in radians, that's good. The radius is 30 meters. The mass is 100 kilograms. And I want to know what is the normal force acting on the person. So this is my Ferris wheel. I have a person at the top. The force is acting on that person. I have a weight going down. I have a normal force going up. And my acceleration is in the radial direction downward. So I say the sum of the forces equals ma. That a is r, and it is a negative value. Sum of the forces is Fn minus Fw equals negative m v squared over r. And I solve for Fn. Fn equals Fw minus mv squared over r. Or, since I have omega, I'm going to write it differently. I'm going to write it as m omega squared r. Remember, we had two alternate expressions for the centripetal force or the centripetal acceleration. The weight is 1,000 minus 100 times omega squared, that's 0.2 squared times r, which is 30, and that's equal to 880 newtons. The fan is switched on. It has an angular acceleration of 30 radians per second squared. Omega naught is 0 because it's switched on. Alpha is equal to 30. T equals 4. I want to know what is the angular velocity. Omega equals omega naught plus alpha t. This is 0. So omega is just alpha times t. That's 30 times t, which is 4 seconds. That's 120 radians per second. You spin a yo-yo and around the world, as in this figure. The yo-yo is attached to a string, travels in a circular path with constant angular speed. Which of these statements best describe this situation? Okay, so tension in the string is least at the top of the circle. That's true because I have the tension, I have the weight, or nope, not that. I have the weight acting downward right there, and my acceleration is downward. So I would say the sum of the forces equals negative Ft minus Fw equals negative ma. And so the tension will equal to ma minus Fw. As opposed to at the bottom, my tension is up, my weight is down, my acceleration is up, and it would be Ft minus Fw equals ma, and so Ft equals Fw plus ma, or ma plus Fw. So you see the tension is bigger in the bottom, which tells me that's not right. The acceleration of the yo-yo is equal to the acceleration due to gravity at the bottom of the circle. That's not true, or at least it's not necessarily true. The acceleration at the bottom is equal to v squared over r. That's the only acceleration that it has, that centripetal acceleration. The energy of the yo-yo is greatest at the top of the trajectory. Okay, that is true because it has the same kinetic energy throughout, but then it also up here at the top, it has an additional potential energy. So 1 and 4 are the correct answers. Rigid object is rotating with an angular speed that's less than 0. It means it's negative. That also means it's clockwise. It is speeding up in its rotation. That means that alpha and omega are the same direction. And so I'm asking, what is alpha? It's going to be A. All right, consider this class 3 lever. What force F is required to hold the lever in equilibrium? I'm balancing my torques. Here I have a 20 Newton force. 20 newtons times 4 equals, or minus F times 2 is equal to 0. That's just the sum of the torques. Notice that I made this one positive because it's counterclockwise and this one negative because it's clockwise. So that's 80 minus 2F equals 0. So F has to equal 40, or B. What is the net torque on this bar that rotates about point C? Okay, so first of all, this force provides no torque because it's at point C. This force provides a negative torque because it's clockwise, and this one provides a positive torque because it's counterclockwise. So I'd have the sum of the torques will be negative 25 times 3. Remember, torque is equal to Fr sine theta, where r is the distance from here to the axis of rotation, or 3 meters, and theta in this case is 90 degrees, which is the sine of 90 is equal to 1. The torque due to this bar, or to this force rather, is equal to positive 10 times 1 meter. That's the distance from here to here. If that's 4, that means this is 1. Negative 65. 65 newtons clockwise. And D. I really do like helping you guys do well in the class. All right, that